In this video, I'm going to show you how to read and write to SRIX4K tags using CR95HF evaluation board. In the previous video, we saw how to use this evaluation board using the software that comes with the board, or that is created by st.com. So I just found out SRIX refers to short range interface with anti-clone function. Never knew this before. So what you're going to see in this video is I have created a software using the VB.NET and the DLL provided by st.com, or that comes with this evaluation board. So I'm going to show you how to read and write to SRIX4K. We are going to see only one tag, because using only one tag we don't have to think about anti-collision, which anti-collision is required only if there are more than one tags in the reader writer field. So by using this, or by assuming a one tag, the programming will be easier. So I just realized how important is this the development software that comes with this evaluation board. We're going to see that first. We're going to see how to do the fundamental operations like activate and select a single tag, and how to read and write to the blocks. So I'm going to show you a software which is very similar to the one I have created for the OmniKey 5321 reader writer for SRIX4K. So I have already made a video on how to use SRIX4K using the OmniKey. So since most of the things are covered in this video, I will not be going in much detail in this video. So please see my other videos where I spend more time and explain everything in very easy steps. So if you have not seen my earlier videos, you can find that in my YouTube channel, and the playlist is called OmniKey 5421 reader writer, and under this you have to see the last two videos. It says OmniKey 5421 SRIX4K tags. You have to start with the video number 3, and this goes to video number 4. So that says SRIX4K tags, OTP and the logs. So please view these videos if you want to understand SRIX4K better. So you have to keep this document ready with you, because you will have to refer this document along with the software as well. Plus, this is not very essential, but keeping this document ready, it's also going to be helpful to you to understand SRIX4K commands. So I have spoken about this document in my previous videos, so please see that as well. So I'm going to show you how to do these fundamental operations using the CR95HF development software. So as you can see, I've connected the reader writer board, and this is the software. Click on the first one, and we are going to use the SRIX4K screen. And as soon as you open this screen, few things have already done for us. I think if you look at this the log file, the first one is an echo command to check whether the connection is right. The next is the board is already configured to read and write for the type ISO 1443B protocol. To know more about this command, you have to refer back to that PDF on how to use this DLL. And the next command is to increase the demodulation gain. This is the documentation says you have to do this thing. So if you are using the DLL, you will have to use these two commands to configure your board to read the type B tags. So I'm going to place my SRIX4K, and this is the same tag I've used when I did my videos on OmniKey, and I've also mentioned that these tags are very expensive. They cost around £3 to buy, so I just don't want to spoil one more tag. I'm using the same one. So the first thing, these are on what you see here is the commands of SRIX4K, and these are also the commands of the type B ISO 1443B part 3 protocol as well. Because I have got only one tag, I'm going to start with the init. The init command, as you can see here, gives out, if you see the documentation or if you read on internet about how this part 3 protocol works, the init command in this case returns a unique chip ID. So SRIX4K has returned a unique chip ID that is hex 24, and the next thing you're going to do is hit this button called select, and when you give the select, you're basically selecting the tag for read and write. So these are the only two commands we need to activate and use the tag when we have got only one tag. If you have got more than one, which I have not tried myself, you will end up using the full anti-collision sequence. I'm going to do that later because that's a very interesting concept to learn. So here also the select command, I know this is a success message because the documentation says 80 is a success, followed by 04 is the length of the response, and the first byte here 24 refers to the chip ID which is returned by the initiate command. So if you get this response, it means you have selected. And just to make sure everything is working fine, I'm going to hit this button, get UID. So bear in mind, these are the only two commands you need when you've got only one tag, the initiate and the select chip and the get UID. After that, you need to know how to read and write. So I'm going to use I'm going to just bring the content of a single page. So here I can say I want to read only one page from 20 to 20, to not just 20, it's hexadecimal 20, it's 32. So click on read block. So we have just read, as you can also see here, the command to read is 08. This is the command from SRIX4K datasheet, and followed by the address, the block address, and this returns us the 4 byte of the data from the tag. So let's go through that. 80 is a success, 07 is the number of bytes in the response, and followed by the first 4 bytes is the data. As you can see here, you just keep in mind that the data is shown as MSB first and LSB, whereas the data you get from the tag is the LSB first, the least significant byte first. This is followed by the 2 bytes of the CRC, which we are not using. So we cannot ignore this. Once you integrate, you will end up verifying that this is correct. I'm not very sure this 00. However, the documentation, that's the how to use this CR95HF DLL, says this is the protocol status. I'm not very sure when this is used, but if you assume that everything is fine, you can just extract the first 4 bytes and look for the first byte, which is 80 as a success. So this is how the reading is done. So as I mentioned before, this software is a very, very valuable thing. You'll this is going to make our the programming or the development very easier. You just have to call this function and send this string. So it's as easy as that. So I'm going to show how to write. So I'm going to change this from 6.1 to say 8.1. I'm just going to delete, select all, and 8.1, 8.2, 8.3, 8.4, and click on write. So there's something different happens here. So when you write, looks like you are getting an error message. So the reason is this is actually not an error. It just it says waiting for data. If you look at the documentation of SRIX4K, it says the write command does not return any response. So the only way to know if the write is successful is to read the same block again. So you have, when you do the programming, you have to put an exception that for a write command, 87 or not having 80 is still as a success operation. So I'm going to read this again. So I'm just going to hit this read. So you can see that the data is written successfully for the tag. Similarly, the read system area, write system is exactly the same, as there's no difference here. If you hit this read system area, it is still same, the read operation, but the address is FF. And you have to keep in mind, you can't just go and update things here. It doesn't work like that, because system area can make your tag locked, and you have to be careful. So I would advise you to see my previous videos and also read the documentation of SRIX4K. So keep in mind, even though it's called system area, it is still the same, the read and the write, and that is the reason why I mentioned that there are 4 fundamental operations you have to be you should know about. That's the init, that's a select, read, and write. And using these 4 fundamental operations, you can create your own software that reads and writes to SRIX4K using a CR95HF development board. So this is the software I've been working with. I've called this as understand RFID tags using CR95HF 1.0.0. This is my first software using this board. The first thing you have to do here is I'm going to connect. So still, as I said, it's still at a very early stage. So this is the screen I've written for Omni key 5421. It's exactly the same user interface, just the way the data is read from the tag I've changed. So as you can see here, these are exactly the same commands we saw using the development software that came with the board. So that's the reason why I mentioned that you have to have that software with you. So here also, in order to initialize the board, I'm sending this these commands, and I'm getting this as a response. And I'm also using this increase demodulation gain, sending this command and getting the response. So next I'm going to place SRIX4K tag and hit go. So as you can see here, so I'm sending a series of read and write. Yeah, I'm sending a series of read and write or so read blocks here. So we have seen these commands. So I'm using the initiate and the select, and as I mentioned before, these are the only two anti-collision or activation commands we need. Then I'm just continuously sending read the block 0, get the block data, read the block 1, get the data, read the block 2, get the data, so on, and the last one will be read the system area. And this is the screen. If you have seen my other videos, it's a same front end, I would say. It's just the back end is different. So let's try to play with this little bit, and I'm going to clear because I got so many messages here. First I'm going to write something to say to block number 16, and I'm going to say, for example, CR95. Right. So the write is successful. Let's see in ASCII. So here write successful. See what is that I have done here. It's exactly the same commands we saw in the software. When you send the write command, I still get this. See, this is the message you get from the DLL. So this is not the message you get from the CR95HF chip. So this I would say this is a very higher level message you get. And after I did the write, I'm going to read, and I got this whatever data I've written. So that's the reason why you see here the write is successful. So there's nothing special here. It's the same command we are using. Let's say the OTP again. Even though it's a OTP or a counter or a system area, everything will be the basic functions either to read or a write. So I'm not worried about working with OTP in this chipset because the OTP values are resettable. If you compare this with the MIFE tags like ultralight or NTAG tags, where OTP is just it's a one-way write. You cannot undo it. So you can easily play with this. So yeah. Okay, so I'm going to write I'm going to write this 4 bytes write. I'm going to write and something like here write. So everything whether write OTP counters, everything is just a simple the fundamental the write and read operations. Okay, and the counter, this is a counter. It's a countdown, so I have to reduce this to, want to change this as a 9999, right? Oh sorry, this is more than that, 9999. Okay, so as I mentioned before, you have to count down, right? Yeah. So let's try to see that everything is fine. I'm just going to close, take out the tag, and try again. Read. If you go to the counters, you can see the counters are written, OTPs are written as well. So in order to clear the OTP, we know that this is the reload counter. That's the counter is page number 6. So I'm going to reduce this to by 1, right? By doing this, all OTP becomes erasable, or also called, the proper terminology is the auto erase cycle is enabled. So I'm going to clear them all back. just clear it. Okay, write and write. The OTPs are clear now. Sorry, I just forgot to remove these two bits as well. Right. Okay, and that is how eventually everything will be read and write. Next is system. So this command is exactly what is mentioned in the software. Get UID. You get the UID. Then the lock. Lock is one way. So if you lock it, that's locked forever. So just play with this with just one lock. Probably I can use this tag in other videos as well. I'm going to lock the 9. Just going to clear everything. So right, so the block 9 is locked. So again everything is a write and a read. That the only thing you have to keep in mind is whatever you see on the screen, it has to be mapped to the proper 4 bytes. So this is where you have to put your skills. So converting the data into the bit patterns, or converting this ticks to back to the 4 bytes. And I think that's all. This how easy is this. So and that's all.